In this video, we're going to look at the synapse. We're going to cover what the synapse is and the reason for having a synapse. We're going to look at neurotransmitters and how they move across the synapse, as well as drugs and their effect on the synapse. When a message is sent along a nerve, it's usually necessary for a number of neurons to pass a message to each other. So it needs to move from the axon of one neuron to the dendrite of another one to continue propagating that message. The axons don't actually touch each other. Instead, they've got a microscopic gap between them called the synapse. In our previous video, we looked at how the message travels electrochemically along the surface of the neuron, and we call this action potential. Once it reaches the end of the axon, the synaptic gap, it gets then changed into a chemical message which moves across that synapse. The way that it moves across the synapse is by neurotransmitters. Neurotransmitters are released from the presynaptic terminal, and all that means is before the synapse. So it's pretty much always the axon, and they pass messages across the synapse. Some common neurotransmitters are acetylcholine, noradrenaline, and serotonin, but there's a number of ones that are used in the body. Once the neurotransmitter travels across the synaptic gap, on the postsynaptic terminal are specific complementary receptors that bind to the neurotransmitters and elicit some response. The response at the postsynaptic terminal can be a response of action to create an action potential in the dendrite of the next neuron and continue sending the message, or it can be inhibitory to stop messages from being sent along that neuron, and the neurotransmitter that gets released will depend on what that response is. Once the neurotransmitters have bound with the receptors and been used, they then are reabsorbed back into the presynaptic terminal, the axon, for use in the future. Most drugs, both illegal and legal, work by inhibiting the function of the synapse, so changing the normal function. And they do this in a number of ways. One class of drugs, called agonists, works by simulating neurotransmitters and binding to the receptors at the postsynaptic terminal, initiating the response that the normal neurotransmitter would. An example of this is THC, tetrahydrocannabinol, and that is the active ingredient in marijuana. It binds to the receptors in the postsynaptic terminal, causing the effects of that you get when smoking that drug. Antagonists also work by simulating neurotransmitters. However, they bind with the receptors to inhibit a response, so to stop the transmission of this message. An example of this is paracetamol, the active ingredient in Panadol. And what it does is it binds to the pain receptors to stop the neurotransmitters that are carrying the pain from sending that message. So we get less pain from that. And another class that we'll look at are reuptake inhibitors. Now, reuptake inhibitors block the reabsorption of the neurotransmitter back into the presynaptic terminal. This results in much more of the neurotransmitter hanging around in the synapse for a longer period of time, which causes the effect of whatever that signal is to be longer and more pronounced. An example of this is a selective serotonin reuptake inhibitor, which is a class of drugs that are given for depression. And what they do is they block the reuptake of serotonin, which is the happy chemical, and therefore in the synapse there's more serotonin, and this improves mood for those people. In this video, we've looked at the synapse being the gap between the presynaptic terminal, the axon, and the postsynaptic terminal, the dendrite. We've looked at neurotransmitters and how they are released as a chemical message to pass across the synapse. And we've also looked at a couple of different ways that drugs interfere with the normal synaptic response, whether they're agonists, causing more of a response by imitating neurotransmitters, agonists imitating neurotransmitters to stop a response, or reuptake inhibitors, which increase a response by stopping the reabsorption of the neurotransmitter into the presynaptic terminal.